All right, welcome to the class for Factoring Trinomials II, trinomials with leading coefficients other than 1. We'll get more into that in just a minute. So first we're just going to review. We're going to factor x squared plus 5x plus 4. Using our rule, we know that the two numbers we're looking for have to multiply to 4 and add to 5. So here are the factors of 4. 1 plus 4 equals 5. 2 plus 2 equals 4. And we're looking for 5, so we know the numbers have to be 1 and 4. So we get x plus 1, x plus 4. And if we were unsure, we can check, and we just FOIL again. Check by FOILing. Okay, so x times x is x squared. X times 4 is 4x. 1 times x is x. 1 times 4 is 4. We have like terms, so we're going to add those, and we get x squared plus 5x plus 4. So we did it. Now we're going to look at a slightly different one. 3x squared plus 13x plus 12. So let's do the same thing before. We're going to try to do our pattern. So remember, it has to multiply to 12 and add to 13. 1 and 12, 2 and 6, 3 and 4. This adds to 13. This adds to 8. And this adds to 7. So we're looking for this one, right? So we get x plus 1, x plus 12. So now let's FOIL to check. FOIL to check. So x times x is x squared. X times 12 is 12x. 1 times x is x. 12. So we're going to get x squared plus 13x plus 12. But that is not equal to what we started with, because we had a 3x here. We had a 3x. So we did it incorrectly. So how are we going to figure out just how to do this? Because our pattern is not working. Well, we have that number in the first term, and we say x times x equals x squared here. So we have to find numbers that multiply to 3. The factors of 3 are only 1 and 3, so we can safely assume that we're going to have 3x and x in our first terms. Now, the last two numbers still have to multiply to 12, because that's always going to be the last step of FOIL. So we're still looking for either these numbers. Okay, so now we just have to keep testing them out to see which way to do it. And we do that by FOILing. So we get 3x squared plus 3x times 12 is 36x. So we can already see that this one's not going to work, because we're going to get a much too big middle term. Okay, so we know it's not this combination. So now let's try 3x plus 12 times x plus 1, because the other, we can reverse those numbers. So 3x times x is 3x squared. 3x times 1 is 3x plus 12x plus 12. So this gives us 15x, so it's close, but it also doesn't work. Okay, so we still have quite a few choices, because we've only gone through both combinations of 1 and 12. So now we need to do 2 and 6. So 3x plus 2, 3x plus 6. Just x plus 6. We're going to get 3x squared plus 18x. So if you're paying attention, this is already too high. We're going to get 20x. instead of 13x. So now we're gonna have to flip those. 3x plus 2, 3x plus 6, and then x plus 2. We're just switching those two numbers from the last one. So we're gonna get 3x squared plus 6x plus 6x plus 12. So this one's really close, but still not quite right, because now we got 3x squared plus 12x plus 12. So now we know it has to be 3 and 4, but we still have to test because we don't know which order the 3 and the 4 are going to come in. So 3x plus 3, 3x plus 4. Just x plus 4. I don't know why I keep doing that. We're going to get 3x squared plus 12x plus 3x plus 12. So this is also not the answer. This is going to give us 15x plus 12. So it must be this last option, 3x plus 4, x plus 3. So we're going to get 3x squared plus 9x plus 4x plus 12. Look at that. So we finally got it. 3x squared plus 13x plus 12. All right, so we finally got our answer here. Well, actually, that's just checking. So this is the answer. This is the answer. 3x plus 4, x plus 3. So what did this problem teach us? What did this problem teach us? I'm just going to erase this stuff so I can write some more. So our trinomial factoring pattern does not work when there is a number greater than 1 in the first term. Okay? So we can't do our simple pattern here because we have this 3. So when we have a number in the first term, we have to guess and check. Have to take educated, they're not completely random, guesses and FOIL to check which combination is right. Okay, so we're going to do it one more time, and then we're going to actually learn another way to do it that is not in this lesson, but for those of you who want to learn a faster way to do it, please stay on the video. But yeah, we're going to do one more example using the guess and check method. So we're given 7x squared plus 4x minus 3. So factor. Okay, so we see we have that 7 here, so we can't use our pattern. We can't use it. But we know the first two terms in our factored binomials have to multiply to this. So we're going to have an x and an x. Now the only factors of 7 are 1 and 7. So we know one of the terms is going to have a 7 and one of the terms is going to have an implied 1. Now luckily we were given this 3 in the last term. It's negative 3. And there's only two factors of negative 3. It's negative 1 and 3 and 1 and negative 3. Okay, so we only have two combinations to check. So it's much easier than the last one because there were 6 combinations to check in the last one. So let's test this one out. We're going to get 7x squared plus 21x minus x. So you can already see this one's not the one, but let's just do it all the way to figure it out. Just to be sure, I mean, 7x squared plus 20x minus 3. Okay, so that's not it. So it must be the other one, but let's just see to make sure. So we're going to get 7x squared minus 7x. Wait a second. Plus 3x minus 3. Oh, I'm sorry, there's 4 combinations. There's 4 combinations. So we're still on this. We're still in this combination. So this is going to give us 7x minus 4x minus 3. So you can see that we're close, but this is a minus sign and we're looking for a plus sign, so it's not this one either. So now, sorry about that. So now we're going to move on to 7x plus 1 x minus 3. So this is going to give us 7x squared minus 21x plus x minus 3. 7x squared minus 20x minus 3. So you can see this one's not right either. Okay, let's move on to the last one. 7x minus 3, x plus 1. So that's going to give us 7x squared plus 7x minus 3x minus 3. And that gives us 7x squared plus 4x minus 3, which was our original trinomial, so the factor is right here. Okay, so this is the guessing and checking method. You have to come up with the first 2 numbers by figuring out which 2 terms multiply to this first term. You factor the last term, and then you have to use these factors to test all the different types of possibilities. Okay? So that's this whole lesson, how MathStart wants you to learn it. I'm going to teach you another way to do these types of factoring problems using the same 2 examples, and it's called factoring by grouping, okay? So if you don't want to learn this other method, if you think it would confuse you, you can just move on to the handout and don't worry about it. If not, if you want to learn it, stay tuned. Let me just erase this stuff real quick. All right, we're going to learn it on this one first. Okay, so this is called factoring by grouping. I'm going to just write it up here. Factoring by grouping. Okay, so we do this type of factoring when there's a number in the first term. Okay, so the first thing we do is multiply that number by the last number. So 3 times 12. And that's going to give us 36. Okay, now we're going to factor 36. So there's 1 and 36, 2 and 18, 3 and 12, and 4 and 9. And I believe that is it. Oh no, sorry, 6 and 6, obviously. Duh. So now that we've factored this, we have to see which one adds to 13. Sorry, those don't equal 13. This equals 37. this equals 20, this equals 15, this equals 13, and this equals 12. So we're looking for 4 and 9 here. So now what we're going to do is we're going to break this middle term into those parts. That's why it's called grouping. So 3x squared plus 4x plus 9x plus 12. Okay? So now this is the difficult part. We're going to break these into 2 different groups. Okay? So we're going to put these parentheses around it. So since I put these parentheses here, I have to deal with what's inside first. So what's the common factor between just these 2 terms? We have a 3 and a 4, so there's no common number, but we have an x and an x here, so there's one common x. So I'm going to take an x out, and we get 3x plus 4. Okay? 3x plus 4 times x would give us that. Now what's the common factor over here? It is 3. All it is 3. So we're going to get 3x plus 4 again. Because 3 times 3x is 9x. 3 times 4 is 12. So we're at the last step now. So if I had xy plus 3y, we have these common y's, so I would pull them out, and I would say I have y times x plus 3, right? Same thing here. We have a 3x plus 4 and a 3x plus 4. So I'm going to pull those out front. I'm going to pull that out front. And now I'm just left with the x and the 3. So we get x plus 3. Okay? And that should be the same one as before. I'm not sure. But let's just check with, we can always check with FOIL. So 3x times x is 3x squared. 3x times 3 is 9x. 4 times x is 4x. 4 times 3 is 12. Add those like terms, and we'll get back our original trinomial. So this is right. So let's just do it another time using this one. So after we do this one, I'll come up with a step-by-step way to do this. But remember, we multiply the first 2 terms together. So 7 times negative 3 is negative 21. Now we 7 times negative 3. Now we're going to factor negative 21. So 1 and negative 21, and 3 and 7, negative 7. Also negative 1 and 21, and negative 3 and 7. So now we're going to add all of these together and see which one gives us 4. Obviously, these bigger ones are not going to give us 4, so don't even worry about those. Well, just for the sake of argument, I'll just show you what they equal. Negative 20 and 20. So for this one, we're going to get negative 4, and this one we're going to get 4. So we want to use negative 3 and 7 here, which is the 2 numbers we had to begin with. But we don't know, it's not necessarily those same numbers, because remember, here we multiplied 3 and 12, we got 36, but then the numbers we wanted to use were 4 and 9. So it's just a coincidence that it's the same numbers here. It's not always going to be those same numbers. So now we're going to use these 2 numbers to break apart this 4. So 7x squared plus negative 3x plus 7x minus 3. So once we break that middle part into 2, now we have 4 terms, and I'm going to group like I did over here. So I'm going to group these 2 together and these 2 together. So now I'm going to find common factors for this one and this one. So here 7 and 3 are prime, so all we have is an x. So it's going to become 7x minus 3. Now, we already have a 7x minus 3, and there are no common factors over here. But we have to remember there's always an implied 1 in front of parentheses. So now we have that common binomial, like we had over here. We had 3x plus 4 and 3x plus 4. So I'm going to factor that whole binomial out. So we're going to get 7x minus 3. And now we're all only left with x plus 1. Okay, same as we got before. I'm just going to FOIL just to double check. 7x times x is 7x squared. 7x times 1 is 7x minus 3x minus 3. Combine those like terms, we will get back the original trinomial. So, cool. So again, this is called factoring by grouping. It's a little more complicated than the guessing and checking way, but let me come up with a list of procedural rules. So 1, multiply first number and last number of trinomial together. Okay, so 7 times negative 3. Factor this new number. Okay, so we multiplied those two together, then we factored it. After factoring, find the factors that add to the middle term in trinomial. Okay, so we found it was negative 3 and 7. Replace middle term with these two new terms. Okay, so we replaced 4x with negative 3x and 7x because those add to 4x. Group the first two and second two terms together. Find common factors of the new groups. Okay, so here I formed two groups, group 1 and group 2. In group 1, I found the common factor of x. In group 2, I found the common factor of 1. Factor out similar, or sorry, I shouldn't use similar, I should use the word like binomials, okay? So the like binomial over here is 7x minus 3 and 7x minus 3. And then after you factor out the like binomials, you should be left with the two binomials that we were looking for. Okay? So I'm just going to do one more of those from the homework using the grouping method. So it's going to be number 1 from the handout. So 5x squared plus 7x plus 2. Okay, so we see there's a number there, so we have to use either the guessing and checking or factoring by grouping. Let's just do this way, just to get more practice. Multiply first number and last number of trinomial together. So the first and last are 5 and 2. So that gives us 10. Now we're going to factor that new number, 10, 1 and 10, 2 and 5. Okay? Not many factors, thank God. Find out the factors that add to the middle term in the trinomial. Okay, so this gives us 11, and this gives us 7. So we're looking for 2 and 5. So like I said before, it's not necessarily always going to be the two numbers you're multiplying with. It's just a coincidence sometimes that happens. But in this case it is. So we found that adds to 7, so we're going to replace the middle term with these two terms. So 5x squared plus 2x plus 5x plus 2. Okay? And now we're going to group. So now we're on to, so we just replaced it, the fourth step. Now we're going to group, the fifth step. All right, so now we're going to move on to the sixth step, find the common factors of each of the groups respectively. So here we just have x. And here again, there is no common factor, and it's also the same as that, so we have to remember that there's already a 1 there. Okay, so now we have the common factor of this binomial. We're going to pull that out, put that first, 5x plus 2, and now we're just left with the x plus 1. X plus 1. So factoring this gives us this. Now we're going to FOIL to check. We're only foiling to check. It's not part of the actual answer. 5x plus times x is 5x squared. 5x times 1 is 5x. 2 times x is 2x plus 2. And we get that original trinomial, so we know we did it right. Cool. All right. Good luck with the handout.